afternoon, students. Welcome. The last time I told you all that today we'll be working on continuous compounding interest and on interest versus interest compounded on a monthly basis in doing compound interest. And we want to find out which one of these two investments pays more. So let's look at the problem that we have at hand. Let's say you have $12,000 to invest, and let's say deposit this amount in the bank that pays an interest of 7%. So R equal to 7%. Let's say this is compounded continuously for 3 years, or time equal to 3 years. And then we will do the same problem using compounding on a monthly basis. And let's look at the difference. So our formula for doing continuous compounding would be A equal to PE to the RT, where E, as we had mentioned before, is the exponential function, E equal to 2.71828. All right, it's an irrational number. So let's go ahead and identify our values here for these variables and substitute them into the formula and find out how much this yield. So here, our future value A then would be equal to our principal of $12,000 times E to the R. Our R is 7%, so that would be 0.07 multiplied by our year, which is 3 years. All right? This is what we will now simplify. So this is equal to 12,000 times E to the 0.21. 3 multiplied by 0.07 gives us 0.21. Now, if you use your handheld calculator, you have a TI-30XA or any other one, they should have the exponential key. Some of them involve just entering the exponent there of 0.21, and then you hit that exponential key, and it gives you 1.233678. So our value here then is going to be 12,000 multiplied by 1.233678. You can leave it there rather than write more. And then we just multiply through, and this is going to give you $14,804.14. And this is your future value. A future value which you get from investing $12,000 at a rate of 7% compounded continuously for 3 years. All right, so then your interest, I, equal to your future value minus your principal, which gives us $2,804.14. So that's your interest. We know the amount A, we know the interest, how much you get. Let's go ahead then and do the same problem using compounding 12 times per year for 3 years. Same time, same principal, same percent. The only difference is that we are compounding it 12 times per year on a monthly basis. So this is A. B. Our formula for this one is going to be A, your future value, equal to the present value times 1 plus the rate over the number of time you're compounding it times n times t. The number of time you compound multiplied by the years. So this is our formula for this one here now. And we already know our principal equal to 12,000, which is the same as above. Rate equal to 7%. Time equal to 3 years. But the important variable that we need to know now is n. So since we are compounding 12 times a year, what are we going to use for n? 12. N equal to 12. So then if we substitute these values into the formula here, we will get A equal to 12,000 times 1 plus 0.07 divided by 12, everything to the 12 times 3. All right, and this is going to give us 12,000 times 1 plus 0.0058 to the 36th power, and that is going to be equal to 12,000 times 1.0058 to the 36th power. Now, what we have here, class, in this parenthesis here, that's what we'll raise to the 36th power. And if you do that, you'll get our 12,000 here, which is the principal, multiplied by 1.2329, and that gives us $14,795.11. All right, this is your amount, or interest, equal to $2,795.11. Now, this one here yield us a less interest than the continuous compounding. Continuous compounding gives us an amount of $14,804.14 with an interest of $2,804.14. Compounded on a monthly basis, the same amount at the same rate for the same time, give us $14,795.11, and our interest turns out to be $2,795.11. So there you see there is a slight difference between these two investments, but our principal amount was only $12,000. So you can see then that continuous compounding yield a higher future value than our monthly compounding. So that should give you an idea of what type of investment you should make with your money. All right? So it's a good application problem, realistic, and we'll be working more of this. In your homework, you have several of these problems to practice on to enhance your problem solving skill. All right? So hope you have that conceptual understanding of how to solve this kind of problem.